Okay, we're working on page 64, numbers 2 through 4, out of the Philip Exeter Academy Math 1, dealing with quadratic expressions and equations. A little test prep for those CP Math 2 students. So I kind of grouped these together, these three problems, because they're very similar and they use the same ideas and techniques for solving. So let's start at number 2 here. It says factor each of the following quadratic expressions. Now in a previous problem I showed how you can factor these, but all we're doing is seeing what common factors, numbers, variables I can divide into each of the terms. So notice there's no coefficient, or there's a coefficient of 1 on the x squared. It's invisible there. So we're not going to factor any numbers out, but we can factor out and divide out an x. They both share an x. So we're going to factor an x to the front. And what we would have left is if we divide x squared by x, we would have an x left over. And if you divide a positive 4x by x, you'd have a plus 4 left over. And that's all we're doing with the factoring. Notice if we multiply back out, x times x is x squared, x times 4x is plus 4x. Now letter B here, we can do the same idea, but this time we can factor out a number. Okay, so what number goes into both 2 and 6? That would be 2. So I can factor out a 2. And because this has an x squared and that's an x, we can also factor an x out. So now what times 2x gives you 2x squared? That would be x. And then 2 goes into 6 3 times, so you'd have a minus 3. And we already divided this x out and put it out in front. Notice if we multiply back out, we would have 2x times x, which is 2x squared, and 2x times negative 3, which is negative 6x. Same thing on C. Now we have a 3x squared minus 15x, so we can factor out a 3 and an x. And it would leave you with an x minus 5. Again, 3x times x is 3x squared. 3x times negative 5 is negative 15x. This last one's a bit tricky, but notice how we have a negative sign out in front. I will actually factor out a negative, but notice that there aren't any whole numbers that divide into both 2 and 7. So I'm not going to factor any numbers out. I'll just factor an x out. Now, it will leave me with a positive 2x plus, because I factored out that negative already right here, plus a 7. And again, the most important thing here is that if you multiply back out, you get what we started with. So negative x times 2x, negative 2x squared, negative x times 7 is negative 7x. And there's our factors for number 2. Now number 3, it talks about the zero product property. Okay, basically to solve these problems, what we're going to do is we want to create factors like we did here. Each of these has 2 factors. And what it's telling us right here is that if these expressions above equal 0, then it's true that either one of these equals 0. So how do we actually use that to solve these problems? Well, I'll do A here. The first thing we would do is factor that out. So we already factored it above. So this, notice here, x squared plus 4x, that's what we had up here. Now it just equals 0. So what we would do is just factor it At this point, we will set each of, get rid of that for a second, each of these factors equal to 0. So I will set x equals 0 and x plus 4 equal to 0. This x equals 0 is already solved. X plus 4 equals 0, I just subtract the 4 from both sides, and I get x equals negative 4. So really this is just an extension of, or continuation of 2. Okay, so on B, I already factored it above, so I'm just going to put the factors here. Equals 0. And then I just take again both of these factors. 2x equals 0, set that equal to 0. Divide by 2, x equals 0. Set x minus 3 equal to 0. Add 3 to both sides. X equals 3. C, I already have my factored version right here. 3x squared minus 15x equals 0. Forgot to factor it. I'll write the factored from above. So I end up with 3x equals 0. X minus 5 equals 0. So divide by 3. X equals 0. And x equals 5. That was a horrible 5, I believe. There we go. Okay, I will do D down here. The factored version of D was negative x times 2x plus 7. So negative x equals 0. So that means x equals 0. Two x plus 7 equals 0. Subtract the 7 from both sides. 2x equals negative 7. Oh, this one's not nice at all. Divide by 2. And we get x equals negative 7/2. Okay? Now for our last problem here. I'm going to kind of move this. Oops, oh, don't do that. Let's just move this up a little bit. Right there. Okay, the last one asks about the x-intercepts. And if you were able to do number 3, number 4 is actually really easy. So what's going on here is it's saying if you have a quadratic, which is basically, parabola. A lot of these parabolas are crossing in 2 places. The coordinates of that x-intercept, and that's what we're looking for, find the x-intercepts. The coordinates would be some x value, comma 0, right? So that x-coordinate is some x value, comma 0, for both of these. So 0 is what y equals. So for the equation of this parabola, if you plug in a 0 for the y, then you'll find the x. So what does that mean in terms of this problem? Well, if you look at A here, if we plug in a 0 for y, we would get 0 equals x squared plus 4x. We just did this problem. We just did it right here, x squared plus 4x equals 0. So it's virtually the same problem. The only difference here is we're talking graphically instead of in equation form. So we could go all the way back down to the final answer right there, which was x equals 0 and x equals -4. The only difference is those are x values. They're not actual x-intercepts. An x-intercept is a point. So my point would be, my x-intercepts would be 0, 0, and -4, 0 for A. Okay? So basically, you're just taking what we had here, the same exact method for solving number 3. And once you have your x value, those x values go into the x values for points with the y equals 0. So this is how easy B is. Here is B, x equals 0, so that would give us an x-intercept on number 4B of 0, 0. The other x-intercept, x equals 3, so it would be 3, 0. C, the x-intercepts are the x equals 0 and 5. So our x-intercepts for the same function would be 0, 0, and 5, 0. And the last one, D. D was right here. It's the same function equals 0. So we do the same thing, same idea. The zeros here would be 0, 0, and -7/2, 0. Now on your test, you can do it like this. You don't have to re-show all this work, but you need to make sure that this work up here that you did, we can see. As long as we can see this work up here, we'll be okay with this. But if you just have these, that's not going to be enough.